So when I'm talking about the area of a kite, if I think about it, the kite is really just these two triangles that are congruent, this left side and the right side that are congruent to each other. So each one of them would have an area of 1/2 times this base times this height, which means when I put those two areas together, the area of a kite is really 1/2 times the first diagonal times the second diagonal. Well, that means, in this case, since this is 3 feet and I know that this is a bisector, a perpendicular bisector, that means that this is also 3 feet. So it's 1/2 times 3 plus 3, and then my other diagonal is 4 plus 2. So 1/2 times 6 gives me 18. So 18 square feet. In this case, I could have broken it down into these different triangles, 2 to 4 different triangles, but if I know this, it's a lot faster just to go directly to that, and they don't always break down the dimensions of the triangles. For example, in this case, it is broken down, but on your test it wasn't, and in some of your homework it wasn't. So Eduardo's making this kite, and here's where people got a little bit confused. The mylar, the balsa wood that he's doing is actually just these diagonals. So for part A, how much balsa he needs? He needs 15 times 2 inches plus 20 inches plus 36 inches. That'll give him the two diagonals for balsa. So he needs 86 inches of balsa wood. Now, for the mylar is actually this whole shaded part here because there's string here going from one vertex to the other, and then the mylar has to overlap the string so it can be folded over and glued underneath, which means that what you really have is this kite shape of mylar. So for the mylar, the kite shape is 1/2 times the first diagonal, which is 15 plus 15, times the second diagonal, which is 20 plus 36. That part is going to give me 1/2 times 30 times 56, and I didn't calculate this separately on my sheet, so let me do this. 1/2 times 30 times 56 gives me 840 square inches. But then you also have these shapes on the side that are trapezoids. These two trapezoids are congruent to each other, and these two trapezoids. So for the smaller trapezoid, the two bases are 25 and 21, so 25 plus 21 divided by 2, that average width, and then times 1 because this is 1 inch wide. So that's going to end up being 23, plus 23 plus these two trapezoids. Well, that average width is the one base plus the other base divided by 2, and then times 1. Now, I actually should say 2 of those because I have 2 trapezoids of this size and 2 trapezoids of this size, which is going to change what I just wrote here. Because instead of 23, it's going to make this 46, and then instead of 37 here, it's going to make this one 74. So then 840 plus 46 plus 74 means that he needs 960 square inches of mylar. So he needs 960 square inches of mylar.